Whenever I tell people I work on researching fronts, I'm pretty sure they think I do something like this. My name's Jennifer Catto, and today I'm going to tell you about how I got into researching fronts, what it involves, and why it's important. So first of all, let me tell you a bit about what fronts are. So the term front actually comes from the military term for the line where the two sides would meet in battle. And this is something like what happens in a front when the battling between warm and cold air. So you can see in the top figure here, if you look at the winter average temperature. So this is the climate. You might have heard the phrase, climate is what you expect, weather is what you get. So at the top here, this is the climate. And you can see that between the warm tropical air and the cold polar air, there's quite a straight line. But on a day-to-day basis, so the figure at the bottom, you can see that this straight line is actually becomes very wiggly. So this gives us the weather. So in some of these wiggles, the warm and the cold air get pushed much closer together. And that's what gives us this battling. So what happens at a front? Well, when you've got this battling with the warm and cold air coming together, the warm air rises up over the cold air. So this can happen slightly differently at warm fronts and cold fronts. So at a warm front, the warm air rises over the cold air quite slowly. So it rises up like this, and it gives you large clouds and rainfall. At a cold front, like the picture shown here, you get descending cold air cutting in underneath the warm air. And this causes the warm air to rise up really quickly. So when warm air rises up, it cools down, and the moisture that's held in that air condenses and forms clouds and gives us rainfall. So in Melbourne, we get a lot of cold fronts passing. We don't get so many warm fronts around here, but we get a lot of cold fronts passing, and they bring a lot of rain. And this is why we see fronts shown on weather maps, because it tells us when the rain's coming. So knowing about fronts is clearly very important. Fronts bring rain, and without rain, we can't survive. Water coming from rain is vital for agriculture, for ecosystems, and for human health. If we don't get enough rain, then we get droughts and subsequent consequences for crops. Too much rain in one go, and we get flash flooding, which also has dangerous consequences. But there's another reason that we're interested in fronts, and this is climate change. So we know that the climate is changing due to increased emissions of greenhouse gases from human activities. But as well as increasing the global average temperature, climate change is changing rainfall patterns over the globe. So one of the tools, the major tool that scientists use to look at how the climate might change in the future are climate models. So these are massive computer models, mathematical models that contain all the equations that govern the motion of winds and oceans. And they're run on huge supercomputers like the one shown here, which would probably fit into the Monash University gymnasium. They're huge. So these climate models use all these equations, and they can tell us about what might happen in the future. But before we can use them to look at the future, we need to make sure that these models are representing the present climate correctly. So we would compare what comes out of the model with observations. But before we can compare the models against the observations, we really need to understand what's going on in the real world. So I got into researching fronts not because of the fashions, but because of a fundamental gap in the knowledge. How much rain comes from fronts. So I remember sitting in my supervisor's office chatting about where to take my research next, and we were discussing the declining rainfall in Perth, Western Australia. So this is a region that's already undergone a large decline in rainfall, and it's already had a very large effect. There's a lot less rainfall going into the rivers in Western Australia, and it's actually had an impact of shortening the cropping season in WA. So there was a general scientific consensus in Australia that the declining rainfall in Perth was due to a decline in the number of fronts passing over that region. But a colleague of mine had recently shown that actually the number of fronts in that region hadn't declined over the past 30 years. So if the rainfall had declined, but the number of fronts hadn't, it must be something to do with the rainfall coming from the fronts. But then we realised that we didn't really know how much rain comes from fronts in a global sense. So when we realised that we were onto something that nobody had really looked at before, we got quite excited about getting started on this. So hang on a minute, why is it that we didn't know how much rain comes from fronts? We know that rain comes from fronts. This is why they show it on the forecast maps. Well, a lot of people have looked at individual events, so weather events, to see what the structure of rainfall is around a front and these systems. And some people had looked at long-term patterns over a few years in smaller regions, so for example in Southeast Australia or in the United States of America. But often when they do these studies, they identify the fronts by eye. So they look at charts of temperature and they identify fronts by eye. So you can see that this is a map just of a smallish region over the world. So this is for Europe and North Atlantic. The number of fronts at one particular time is huge. So imagine if you had to do this looking globally for the past 30 years, you can see that that would take forever. And another problem with doing this by eye is that a different set of eyes might see different things. So if two people looked at the same maps to identify fronts, they might actually count a different number of fronts. So this is why it's very difficult to do manual, so by eye analysis on a global scale. So luckily around this time, a colleague of mine had developed some new software to identify fronts automatically. So the first step of my work was to apply my colleague's snazzy new software to some gridded data. So this is gridded data that is our best observational estimate of the state of the atmosphere. And these data sets are produced by taking all the observations that you get from land-based observing stations, plus satellite information. They ingest it all into a big computer program, and it spits out the state of the atmosphere every 6 hours for the past 30 years or so, on a global scale. So you can tell that that's a lot of information that we're dealing with. So I set this new software running on this data set. There's no cool user interface to do this. It's just a case of typing a command into the computer and letting it go. So that's identifying the fronts. So the next thing we needed was rainfall data. So when you want to look globally at rainfall, you're a little bit limited in the data sets that you can use. There are some data sets globally that give you information about rainfall on a monthly basis, but when we're considering fronts that pass over in a day or two, we really need higher temporal resolution information. So the data set we used was actually based on mostly satellite information, but mixed with rain gauge data. But one of the drawbacks of this data set, which was actually daily information, one of the drawbacks is that it was only 12 years long. So this isn't very long when you're doing climate studies, and it isn't long enough to look at long-term changes in rainfall because there's quite a lot of year-to-year variability in rainfall. So with the fronts identified in the gridded data and now the rainfall data, the next step in the analysis was to find a way of linking these two data sets. So here you've got rainfall in the colours, and the fronts are shown by the black lines. So we came up with, we tested a few different ways of linking rainfall and fronts. There wasn't really any right way of doing this, so we tested a few different search areas. So if you looked at this by eye, you might associate the rainfall with the fronts in a certain way. But the idea was we wanted this to be automatic and reproducible so that somebody coming along with a different rainfall data set would be able to apply it in exactly the same way. So we tested some different areas. So we tried a very small box, but then we realized that we'd be missing some of the fronts that passed over quite quickly, or fronts that were maybe slightly further away from the rainfall. But too big a box and all the rainfall over the globe would be associated with fronts. So we compromised and went with a fixed area box that we thought was the best search box. And like I said, the idea was that this could be reproduced by anybody with any different data set. So gathering the data, writing the code to do all the analysis probably took a couple of months of work. Then we had some results. So the main result that we found, or one of the main results that we found, was that in the mid-latitudes of the globe, 68% of rainfall comes from fronts. Okay, so that sounds like a fairly simple number for so much work, but really nobody had found this number before. Nobody had looked globally at how much rain comes from fronts. So yeah, we were the first people to come up with a number like this. So obviously we had some more detail in the results. So you can say that in different regions, so over Southeast Australia, about 70% of rainfall comes from fronts. Over Scotland, where I'm from, about 80% of rainfall comes from fronts. And there's a bit of a different split between cold fronts and warm fronts for rainfall. So in Melbourne, for example, we don't get many warm fronts, so more of the rainfall comes from cold fronts. Whereas it's, in the UK, for example, it's a bit different. There are maybe more warm fronts than cold fronts. And another thing that we found was that the rainfall coming from fronts is actually twice as heavy as rainfall coming when there's not a front. So this wasn't really a surprise because we know that fronts bring a lot of rainfall. But again, nobody had quantified this number. So we wrote up these results and we sent them to a really good journal. And when you send papers to a journal, they get sent to at least 2 reviewers who can comment and criticise and give their suggestions on your work. So we got the reviews back, and one of the reviewers loved it and thought it was great, loved what we'd done, thought it was really important and that it should be published. The other reviewer had a few criticisms. So one of the criticisms was that if we had used a slightly different technique, we would have got different answers, which is true. This is why we tested the different search areas. This is one of the interesting things about science, is that there's very rarely a right way of doing something. It's more, this is the best way we can come up with right now, and we can justify it with these arguments. So we justified our choice of search area based on the speed that fronts move and the previous studies that have shown what the structure of cloud and rainfall coming from fronts from individual events looks like. So having to argue these things with the reviewer, it can be a little bit frustrating, but in the end, it means that you probably didn't justify your choices well enough in the paper to start with. So it can be quite a useful exercise. So much to my relief and delight, a little while later, the paper was published. And it is a large part of what we do is writing papers, but I always think it's cause for celebration when a paper is published. So I probably celebrated with a few Tim Tams at morning tea. So this paper has really been a jumping off point for my more recent research. So now that we have a better understanding of the real world and how much rain comes from fronts, we can then use this to evaluate our climate models to ensure that they are representing this correctly. And then we can then further look at what might happen in the future. How will the rainfall patterns change and how does this relate to fronts? So we'll always need our forecasters to tell us when the fronts are coming, but maybe in the future the fashion and the hairstyles will be a bit different. So thank you.